So for today's Fusion class, if I need to click on this and make it big. For today's Fusion class, we're going to make this little knob. We're going to draw this knob up in Fusion. This knob goes on the top of a little valve for an automotive R134A refrigeration manifold, and someone cranked down really tight on the needle valve and split the bottom of the knob there. So what I want to do is 3D print this knob because the rest of the valves is still good, and I thought that going through the exercise of drawing this up would show you how to create a solid in Fusion, and then also how to set it up for 3D printing. So what I'm going to do is take a pair of calipers like this. I've got just a regular set of kind of cheap Harbor Freight digital calipers, and measure everything up and figure out what I want to do to draw it. Now there's a few things. This being a plastic injection molded piece originally, has this little recessed kind of cavity or channel on the underside. This is so when you plastic injection mold a part, you kind of want to keep the same wall thickness all the way through the part. It helps with making a predictable cooling or shrinkage. When the plastic part cools, it will, if it's thicker, it will shrink differently than if there's a thinner part. So kind of a plastic injection molding rule is to try to create parts that have uniform wall thickness throughout the whole part. So that's why this area out down here is hollowed out. So I'm not going to do that. I'll just make this solid on the backside. And then the other thing is that there is a slight taper on some of the faces on this knob, because from the injection mold it had to get pushed out of the mold. So to make it pop out of the mold easily, they put a little taper on the surfaces. So we're just going to draw it up straight and plain. Again, for 3D printing, if we were going to injection mold it, we would have to incorporate those features. But for 3D printing, we're going to just kind of make it optimized for 3D printing and draw it up that way. So I will do on the top side, I'm not going to include any of the writing. It says, like open and close. But I will do the recess here. The recess is for the screw head. We'll do the little pattern around the outside for the grip pattern. And then on the back side, we're going to do that little profile. It's actually like a circle with two flat sides on it, so it grabs on. So with that, I'm going to share my Fusion screen, and we will get started with drawing it up. So I've typically mentioned that it's a good practice, especially when you do multi-component or multi-part designs, to always start with a new component every time you create something. This being just one single item, and we're not going to, it doesn't have to connect with anything or mate with anything. We can just start creating our object right here, just under kind of the top tree level item here. So if I go to start making a sketch, it will start creating bodies and sketches right under this level of the tree. I don't need to make an extra component for it. If I had a design where I was going to make the part that mates with it or something like that, that's where I would certainly do the, add multiple components to it. So I'm going to start by selecting one of the planes. We'll select this bottom plane here for my sketch, right? So I chose the sketch button in the upper left here. I'm going to create on this plane. And we'll start by making a circle for the overall body dimension. And I actually took some measurements and wrote them down just to save a little time. So I know that, so I am in the millimeter workspace, and I've measured it up in millimeters. So I know that the OD of this is 35 millimeters. So I can either set it, click here to set the circle, and then put a dimension on, like that, and then type in the number that I want and it'll scale it. Or another method is, let me just delete that. When I go to create the circle, it has that that number, that dimension highlighted in blue. I can just type in right now, I can just type 35 and it'll make it 35 millimeters right off the bat. So that just, and it adds the dimension and it saves a step. The only thing that it does is it always puts the dimension inside. And so if I need for clarity or to see better, I can move that dimension around and change it if needed. But 35 is what we're looking for. And then for that little scallop feature, that scallop feature is circular or a curve. It's an arc. I measured it up to be 12 millimeter diameter, and there are 8 of them around the edge of our part here. So I'm going to start by, there's a few ways we could do this, but I think the simplest way is I'm going to make another circle. And so I know that the center point is, somewhere along here. Like as I just move the cursor around, it kind of floats around. I move the cursor over to the center of this circle, and now it gives me a blue dotted line as I start moving vertically. And that's kind of like a snap to line, because now if I try to move to the side, it'll eventually jump to the side, but I can kind of snap it to that vertical position. So I'll snap it to that vertical position. This is going to be 12. And then for its distance away from the center of the other circle, like it, well, I can now move it all over. So actually, I'll do one more thing here before we set this distance, and I'll move it a little bit offset from that vertical line there, because what I want to do is create a construction line. I'm going to create a line from the center point, just kind of straight up. The length is not necessary, and I'm going to hit escape so that it's just that one segment. And I'm going to select this line, and I'm going to click the little construction button over here on the right in the sketch palette, and that's going to make that a dotted line. And if you look, there is this little sawtooth pattern for this line, so that is our constraint, our vertical constraint. So this line is perfectly vertical, and it also starts right at the origin. So those two little symbols down there are our coincident constraints. So now that this line is here in vertical, I'm going to constrain the center of this new circle to that line. So I selected the line and the circle, and it snapped it there, so that now if I look at it, it has that coincident constraint as well. So now if I grab the circle, I can move the circle up and down because it doesn't have a height constraint yet, but I can't move it side to side. So we're just going to eyeball this. We're going to say it's about maybe like that. And then what I'll do, so the circle is blue because it's not, fully defined, where the big circle is black. I'll put a dimension on here just so we can see what it is. So actually, it's real close to 20. I'm going to make it 20 just as a round number because I'm kind of anal like that. And then what I'm going to do is use the scissors, and I'm going to trim the outside of the circle. So you can trim segments, and if you look right now, it's highlighting just this kind of right-hand side of it because it's a segment that's touching this circle and our construction line. So I can trim that line, and I can trim that line, and then I can trim this line and this line. And so now we have to find one of the little grip scallops that's on there. I'm now going to use, under the create feature, there is a circular pattern function. I can choose the circular pattern, and this will allow me to duplicate this. So the first thing that's highlighted blue is the object. So it wants me to select the object that I want to copy for the pattern. So I'm going to choose that part of the arc, and then it wants a center point. So I can click. So I have to manually select center point because I could select as many as objects as I wanted here. So when you're done selecting your objects, you choose your center point, choose the center of the circle, and then now it has popped up down here with a number in this box, and it has the circle here. So I know that I want to make 8 of them. So I can just increase this number to 8, and then there we are. Those are our eight items. And then actually, if I make this box, can I make this box taller? I don't think I can make this box taller, but as I'm scrolling, you do have a few more options. You can type in the number, the quantity that you want here. You can do the spacing. There's different options for the spacing. So I've asked it to do, full around the circle. If I did angle, I could say an angle. So like right now, it's at an angle of, is there an angle number typed in? Yeah, so 180 degrees. Let's just make this 20 degrees as an example. So what it's done is it has taken the geometry that I want to copy, and it has made 8 instances of them each one of them 20 degrees apart. And so that's why they're all kind of here nested together. So let's say you wanted a pattern to only be on part of the circle or something like that. That's what that option would be for. But I want it all the way around. So when I do it all the way around, it's going to divide it equally into however many segments I've asked it. There's also a suppress feature. If I click on suppress, I can then, there's a little checkbox next to each one. If I uncheck a checkbox there, so the spacing is still 8 for the parameters, but it's not going to draw the one that I've unchecked. This could be good if you're doing like a keyway or some kind of keying thing. But for this, we're gonna leave it there so that it creates all 8 of those. I'll be able to click OK, and there they are. They all are on my circle. Now I think I want the little part here between the circles to just be a little bit larger. So let's make this 20 millimeter dimension and let's make it 22 millimeters. And it should update all of the kind of the child entities for that arc there. So as I made it 22, I made them all smaller. That was actually way smaller than I wanted. So let's see what 21 looked like. Let's go with 20 and a half. There we go. I like that. That looks about right. So again, because these are all related, and if I click on one of these, you can see this pattern symbol in the center. So this pattern symbol is the constraint for the pattern here. And if I click on it, it actually says down here in the lower right, circular pattern constraint. So the last step I'm going to do is go back to my trim tool, my scissors, and I'm just going to cut out each of these pieces of the original circle. And there we go. And I'm now going to finish this. And so a message popped up that says, warning, constraint and or dimension were removed during this operation. So just sometimes as you delete segments of entities, like let's say it's dimension to a corner and you make the corner a radius, or you take a line off or do something like that, sometimes it will delete something that has already been defined. And so it gives you a warning here. I typically kind of just ignore them unless it's something important, because I still have all of my entity in black and I still have it shaded blue. So it's a closed solid. So as far as I'm concerned, everything is still good. And so I can finish my sketch, and then there we have it out there in space. So I'm going to use the Extrude tool, this one here, which will take a profile and make it into a solid. And I know that I need to come up this way. It's actually going to come up to 9.5 millimeters. There we go. So that's the top part of our knob. So let's go to, we'll make this side that's up be the side with the feature that goes onto that pin, just because that's the more interesting one to look at. So I can now go to create another sketch. And if you look here in my timeline, right? So we've got this one here is that first sketch, and then this is that extrusion that made it into a solid. So I'll make another sketch, and now I'm going to make it on this top surface. And so it'll pop up here. And because it's still, around the origin point there, I'm going to make another circle. And if I start it from the origin, it will snap to that spot. And so let's see, this is going to be 16 millimeters diameter. So again, it is registered black. It's happy with that. And for this sketch, I'm only going to make this much of the feature because I'll do the next feature in another sketch, because the depth of that feature is going to be a different amount than any of the other things on there. So then I can specify the depth. So I'm going to finish this sketch. And now I've got, this surface. So now when I go to extrude here, I can choose whichever profile I want to extrude, right? I could choose the outside or the inside of the whole thing. But we're going to choose this circle for our extrusion. And then this is going to come up, it looks like 3.5. So 3.5 millimeters up. And so it has created this. And so it's done a few things in the background here, right? So it's now part of our solid model. It's now all one piece. We see it in our tree here, right? This was our extrusion. If I double click on this to look at the extrusion, you know, up here at the top in our edit feature pane, you know, we've got the profile selected. We've got the start where it's going to start from. So it's going to start from the profile plane where it's created. You can change this. You can make it start a little offset or above the plane or a distance. But typically, I will use the profile plane just because from like a logical thinking perspective as I'm creating things, that seems to make the most sense to me. We're making this feature go one direction. So that's this one-sided direction. There's sometimes you want to make things go symmetrically or in two directions. And when you go two directions, you can either do it symmetrically. So if I did 3.5 millimeters, it would make it 3.5 millimeters on both sides for 7 total. Or you can do two sides and you can give different dimensions or different constraints for each of those sides. We're sticking with one side. Again, we're doing distance. Other than distance, we can either do it to an object, like we could choose a surface or a reference plane or some kind of entity to go to, or we could do all. So it would just go through everything that's there, all visible bodies, but the distance is what we're using. We type in our distance. If we wanted to type in a taper angle, we could. Again, that could be useful if you're doing injection molding. And then down here for the operation is join. So a join is, it combines your new body with your existing body. You can make it a cut. That's what we're going to be using for the next spot where we cut the hole out. Or you can make an intersection where it's only the two, you know, where two bodies overlap. You're just keeping that one area. I think on that first day we were talking about that with threads. If you had a bolt made that had threads on it and you put it into another body, you could create or to create the spiral around the threads, do something like that with an intersection. Or you could make it a new body. You can make it a new body, and then that way you could work with it independently. But for our needs, again, we want it to be a join. We want to be part of that first body. So there it is.
Could you make that in a negative number if you wanted it to be recessed versus the?
Yeah, absolutely. And so in fact, so Fusion is smart enough. If I make this negative 3.5, it's going to, so if I do a join, not much is going to happen because it's still part of this. But when you just type it in at first, Fusion will usually realize that that's going into the existing body and it will make it a cut, right? So then that would be a cut. So if I go back to that, right? So if I made it go down, if I here did the intersection, right, it would only just be this little slice, this little pie slice, you know, where the two bodies overlapped. Does that make sense? Oops, let's go back and make it our 3.5 and make it a join. Oh, so in fact, an error popped up here, right? When it still said intersect and I made it go above the part, it said, you know, no target body was found to cut or intersect. But now it's a join, so now it'll be happy. All right, so now let's do our profile in the middle. And so again, we'll do another sketch for that, and we're going to do it from this top plane. Again, we'll start here, and so I measured it. So we're going to start with a circle, and this circle is a diameter of 7. I'll zoom in a little bit, and now this circle had 2 flats on it. So I can use my line tool, and I can just click the circle and click over here. And if you look, it does have the constraint, the horizontal constraint has popped up on there. So I can make that, and I'll make another one over here. And so it's actually popped up another constraint on the second line, which is a parallel constraint. So it made the second line parallel to the first line, and it made the first line horizontal. You could do it by making the second line horizontal. You know, there's a few different options there, but this is the way it wanted to do it. And so that's fine. And now to dimension this, right? So these are blue because it doesn't know exactly where it is. I'm just going to move this dimension out a little bit so it's easier to see. So I can dimension one of these flats to the center of the circle, right? So I'll pull it all the way over so we can see it better, right? And so that's coming up 2 point something. So it's 5.5 across all of there. So so that's going to be 2.75. going to be half of that. And I could also do with the math, right? I could actually do 5.5/2 for 5.5 over 2, and it will, do that math for me. So you can type in math functions in those dimensions. All right, so now this top line is black because it's happy with, it's being fully constrained. And so now we have to do the same for the bottom one. And so I'll do the same thing. I'll do that for this one. And here I'll just type in the 2.75. So now we have that. And then I'm going to go with my trim tool, my scissors, and I'm going to take out the top and the bottom and finish this sketch. And so now we have this profile, and this is going to be 5.5 millimeters deep. So I can do extrude, select my profile again. So it's starting at the profile plane. It's going to go one side. The distance is going to go -5.5. Sometimes if I'm unsure which way to go, one of the things I'll do is once I select my profile, you get this little blue arrow. I can drag this arrow and I can go up or down a little bit, and I can say, oh, okay, down is going to be in the negative direction. So sometimes I'll move it a little bit, and then I'll come over and then type in once I kind of see what direction it wants to go. So again, -5.5. So that's our cutout there. And no taper, and there is an angle thing here. This is that taper angle, right? I could drag this and I could make it either tilt in or out. But again, we want this to be 0. And then OK, and it had automatically selected a cut because it was going to go into the material. So the next thing we'll do is we'll go to the other side of the part, and we'll make there's actually a hole that goes all the way through the part, and then there's a little recess. So we'll do the little hole first. In fact, I'll show you, we can draw both of those circles. So I tend to like to break features out one sketch at a time because it's a little bit easier to go back and edit them. But I'll show you here, right? So we'll choose the top of the knob here as our sketch plane, and we'll make 2 circles. One is the little circle that goes all the way through. That is 4 millimeters. And then there's a circle that's a little larger, and that is 10 millimeters. So I've got 2 of those circles on there, and I'm just going to drag their dimension numbers again away so that they don't overlap. There we go. So our 4 and our 10. So if I do finish sketch, we have both of these here now, right? So we'll do the bigger one first. So in it, I explained earlier, about the tree structure here, right? We've got these little arrows to show you more. So right now for the body, we've just got this one body, right? If I click here, it kind of highlights it. I can select it. There's a little eyeball. I can turn it on or off. And then under it, we have sketches. So here we can see all the sketches that I have made so far. I've made 4 sketches. And if you can see, the 4th one has the eyeball on. It's visible. The other 3 are hidden. What has happened is once I've used the sketch to create a feature with the extrude tool or revolve tool, it will hide that sketch for you. So like right now we've got sketch 4. It hasn't been used yet, so it's still visible. So I will choose this circle. So if I only choose this circle, this part of the profile, it will, so it's going to go up 3.5 millimeters deep again, right? So it's only choosing the just that outer part of kind of the ring or the donut. So it would leave a stub in there. So under the profiles, I have to make sure that, with the blue profile selected, I can select this profile also. And then it will do both of those profiles to make that pocket. So now I can do, and it's a cut, I can do OK. And there it is. So there's my little pocket. And now my sketch 4 is now hidden, right? The little eyeball's turned off on it. So if I want to use that sketch again, I have to click the eyeball. It shows me that click again. And then now I can extrude again, and we can choose just the smaller inner circle. And, I can either pull it this way and give it a number. I can just let it float in space. or I could give it that constraint here for the extent, all. So if I do all, it will just go all the way to the other side, which is really inside that pocket, right? You can kind of see where it went to for that all. And then I'll do OK. And now since I had already, Fusion had already turned the sketch off automatically, but I turned it back on to use it again, it will now not turn it off automatically a second time. So that sketch is still visible there. So with that sketch still visible, I can hide that, and then that's our knob. That's kind of the base geometry of the knob. If I want to pretty it up a little bit, there's some things I can do using some of the modify tools. Like maybe we want to give a little radius fillet here at the top, just to make it look nice. Let's see, is one too much? Yeah, one's kind of nice there. We can give that a fillet. We can maybe give this side smaller fillet, a half. We could. One neat thing about Fusion, right? So that gives it a little bit extra character, kind of deburrs it or breaks the edge a little bit. If I wanted to make a fillet all the way on the outside of this, all the way around, running around, I can choose the fillet tool, and I can click on just one of the edges, and I think, will it do? Actually, it probably won't. So here, we'll show you one thing here, right? So if I do this at 0.5, it will make, actually, I think 1 would be better, but it just does it for just this one little scallop, just this one little spot here. But what I'm going to cancel this, because what I want to show you is let's round off these edges a little bit so that we have essentially a tangent curve leading from one arc to the other arc. So we'll create this again. And so I'm going to select a bunch of them. I'm going to select all of these guys all the way around. You have to make sure you choose the edge and not a face. And it turns blue when I've selected it. And I'll use my view cube to rotate to select more of them. So there should be 16 total, being that there's 8 of these. And let's see, it looks like one more to get, this one here. All right, so I'll make this 0.5, give it just a little bit of a curve. So I've selected 16 edges. It has a fillet of 0.5, and then it's tangent, so that it'll go tangent to the lines around it. And it's a constant radius. I've selected the features, and the rolling ball method is good. I can do OK. And so now we've got a little bit of a curve on all of those. And now this top section, this line kind of flows from one to the other. So now if I do another fillet on the top surface on this edge, it's now selecting that whole edge. So now if I do, let's say, a 1 millimeter fillet, it has kind of gone around all of the corners, and it has done the math required to figure out, how to do those little segments. And so, yeah, your choices are setback and rolling ball. And for this one, it might not make a difference which choice I'm selecting. So I do OK. And
serrate the edge where you do the turning, for like a better grip, like a wet grip.
Yeah. You'd probably have to make like little notches or marks or something, or little cuts, and then you could copy that feature around. So like we made in the sketch, in that first sketch, we made the little single cutout and then copied it around. We could make this feature just one time here, and then we could also do the copying here at this level. So if you wanted to make like lots of little lines or sharper lines, you could do that. If you wanted to make like knurling, you could do that. You'd probably make a diagonal line as a profile, and then actually it would be more like a helix line, right, going around the edge of an object, and then make a little cut out of it. You'd probably use the sweep function, so you'd make a helix line coming around your curve, and then you would use the sweep function where you choose a profile, which would be the helix, and then maybe make a little triangle cut, a little triangle profile, and that would be your profile that removed material. So you could do that to create kind of one groove, and then use the there's a is it under the create, the pattern feature here. The pattern allows you to do rectangular patterns, circular patterns, or pattern along a path. So you could do a circular pattern and make 40 of them all the way around the knob. Does that answer your question, Joel?
Yeah, it does. Thank you.
Okay. Yep. So there. So I guess since we did that top edge, it might be nice to actually do this bottom edge as well. So like I have that top edge done, I could create another radius for that bottom edge, or because it's the same kind of profile and size, I can go and modify that the feature that I just created, the existing fillet feature, and I can do plus here. I can add something to the list, and I can choose this edge as well. Excuse me, and give it the size, and it'll do that. So that has made my my feature. So that's about, I think, all we need to do to create it to 3D print. So we've made it so that it, my plan was we'd probably 3D print it with this face down on the build plate. And so it would build up. One thing to be aware of with 3D printing is that unsupported geometries can sometimes be a pain. Unsupported means that the machine is trying to lay filament down and there's nothing underneath of where it's trying to lay, and so gravity will pull it down and it'll sag a little bit, and it'll be a little bit like spaghetti. Small features, it can do unsupported runs for small features, and really this inside part here is pretty small. So again, if this is being made, if we're kind of looking up from the build plate, right, it'll build layers and layers, and when it gets to this surface, it will have to, start putting material across, and it might sag down a little bit, create a little bit of like a little spaghetti ceiling. But it shouldn't be too bad because it's a pretty small feature. If you had a big cantilevered feature, that could be a problem. Like if we were going to make it this way so that this surface was on the build plate, this whole, this surface would have a hard time being created in the first few layers because the filament will just sag down. So that's why I'm going to make it with this side down. So to 3D print it, the directions would probably be a little bit different for if you are using what type of 3D printer you're using. I have an old Makerbot, which has the Makerbot software for doing that, which I'll show you how I would create my 3D, get ready to do the 3D print for me using the Makerbot software. But if you have another brand 3D printer, the steps you would take to set it up might be a little different. What you would start with, first we're going to save our model here. Before I move on, are there any other questions about creating this, how I created this, or why I created it in this in these steps? Okay, good. So I'm going to save this. I will save this in my tutorials folder, and I can share this model with everybody. So we're going to call this just knob. And so I've created I've saved the Fusion file. One of the options is to export it. And if I choose export, I can choose a file type. And I know that some 3D printers can probably take step files. I know that my 3D printer likes STL files. So I'm going to save it as an STL, and I'm going to save it locally. Let's see, 3D object. We can just put it in this folder here. So knob. So it'll save knob. And then I can click export. And when you save as an STL, some jobs, I guess there's some mathematical computing power that's required to kind of turn the solid into the or turn the Fusion solid into the STL, it uses the Autodesk's cloud resources. So it's not using, I don't think it's using my computer's processor. Maybe it is using my computer's processor some, but I think it's distributing the load over the Autodesk network. And so it'll take it a few minutes to generate. While this is going on, you can still do other stuff. I can close this, and it's one of these buttons up at the top. The little clock is job status is, and I can see, you know, what it's working on. If I click View Job Status, it will show me this. So in a minute, hopefully it'll finish up, and I can show you the next step. In the meantime, while we're waiting for it, I'll show you a few other features that Fusion can do, right? So we've created, you know, our object here. It's to scale using millimeters. We can look at the properties of it. If I right-click on knob, there's a properties menu, and we can see. So, like right now, it currently has been assigned the property steel just because we've done nothing to it. Actually, I want to do this at the body level, not the top level. Let's do this at the body. If I do properties on the body, it will tell me like the area, the surface area of the part, the density, and again, this is based on steel, the mass, and the volume. So we can, if we assign this the material, if I go to, I think it's appearance, and if we choose a material, let's see what there is under plastic. So my printer is PLA. I don't know if that's one of the choices. I don't see that there. I see ABS as a choice. Oh, I have to click and drag it onto the body to assign it. But I wonder if can I do the physical material? What does that? In this design from the Fusion library, plastic. Polycarbonate, ABS. Yeah, they don't have PLA. We do have a lot of other plastic choices. Down to rubbers, silicons. So we'll stick with that one for now. Yeah, we'll stick with the ABS that I already assigned it. So now if I go and I look at it says my export is ready. It just popped up on the window here. Export of knob STL is ready. Okay. But now if I go to my body and I look at my properties, it will now have updated, you know, the density and the mass based on the material properties here. And it'll show me like where the center of mass is, things like that, the moment of inertia. And so these are the, you know, the coordinates that are where the center of inertia is mathematically. All right, so we've created that for created the STL. So let me, I'm gonna just turn off my sharing and open up Makerbot here for a sec. Here we go. So hopefully you see the Makerbot software here.
We do.
So
yes,
in this,
it's there.
good. So this is it's a nice little program. Again, this is relatively old. My Makerbot is the Replicator 2, which is like 10 years old. I got it used a number of years ago. But I can go to File, and the first thing I do is I add. So add my STL. So we put it in the 3D object folder. Here it is, and so there's my knob. So it puts the knob right there on the build plate. And so I only have a few simple tools. I've got my eye, which allows me to rotate this around. Of course, I'm not going to print it, you know, this way because I don't think it would come out well. This tool below it is move. I can move the item around, and then this tool below it is rotate. And if I click this tool again, I can actually get some options for changing the rotation. I can move things 90 degrees. And so let's see, it looks like I need to go this way. Yeah, so then that way I've rotated 90 degrees. So the surface that I want down is down. And if I look at it now, it's now hovering above the build plate. So that's not very good. That's not going to work. If I go back to this rotate one, one of the options is lay flat. And actually under the move one, it's on platform, but they do the same thing. So if I go and do lay flat, it will move it down to the platform. And so now I can see it's right there on the platform. So it's there now. I have a few options for, oh, and this last one here is scaling. If I click this, I can scale it up or down. I can scale it either uniformly, like let's say I want it to be 10% larger or 50% larger, or I could scale a specific axis. The next thing I do is check my settings. So the settings are how the printer is going to print it. So I use PLA. The standard quality is the build quality here. It has the layer height. So the layer height is going to be 0.2 of a millimeter. This is its standard stuff. And then it has number of shells. And again, these are all the standard parameters that Makerbot uses. So I have the number of shells at 2. This means like the top and bottom surfaces and all the exterior walls will all be two layers of filament thick. And then the inside is going to be what's called the infill. This one here, infill, is going to be 10%. So it's going to make the inside of this mostly hollow. It's going to create a little bit of material in there to help support it as it builds, but it's going to be relatively hollow. The material is the Makerbot PLA, and the extruder temperature is going to be 230 degrees C. There's two options here. One is for a raft. A raft puts a platform or like a little plate under it. I find that on my 3D printer, it's usually not necessary. If you're making like a large part and it's tending to warp, or maybe if you're doing something that touches the build plate in a few different places, the raft can be beneficial. Maybe if you're using ABS and you have a printer that has a heated build plate, the raft might allow you to start putting a layer down before you actually start getting to your part. But I typically do not build with a raft and build parts right on the build plate. And then support, you can let it try to figure out if you do have unsupported geometries, it can try to put in areas or build up sections of plastic as it's building to help support those cantilevered areas or overhung areas. I find again on my printer, on the Makerbot, those supports, you have to break them or cut them off. They tend to not break off cleanly. And so then you're actually spending a lot of time with like a little clipper to try to cut them out, or sanding or filing. So I try to always design parts that do not need any kind of supports, and keep that turned off. So those are my settings. And when I'm ready to go, I can export to a print file. When I do that, it tells me asks me where I want to save it. I'll put it in the same one. This file, the X3G file, is the Makerbot format. If I save that, it will export and think about it. And then when it's done, it will allow me to look at a preview. So it's telling me, so again, just the summary here, the resolution is 0.2 millimeters, wraps are off, supports are off. If I do print preview, it shows me here what it's planning to do on the build plate. And so it's 70 layers. It's telling me it's going to use about 3.9 grams of material, and it should take about 17 minutes to print. And I've got this slider here for the layers. And if I go up and down, you can see how it will create, the first layer and the next layer. And then as it starts to build up, you see this hexagon honeycomb pattern kind of starting on the inside. This is that 10% infill. So the Makerbot replicator will create this hexagon pattern to help fill in the inside, to give it some rigidity and to give it support for the layers that are going to come above it. But it's not solid plastic this way. And so it builds those honeycomb layers. And now we get to this top part of that little pocket. And you can see it's got, two walls around the hole of the screw there. And then we start getting to our pocket with the two flats for the shaft. And so that pocket is starting before we start capping off the top of the underside of the knob. And so then that gets topped off, and then we keep building this part up, and then that part gets topped off. And so that's how the computer's planning to do it. There's also a show travel moves, which there's not that many travel moves, but what this means is if you have multiple parts laid out on the bed, you can see how it would do the travel moves. But this little line here on the front is it does a little a line to kind of clear the nozzle. When it first starts, it'll heat the nozzle up, come here to the side, lay a bead of plastic down so it's got smooth flow, and then it'll go to where it wants to start making the model. And then when it's done making the model, the build plate will motorize all the way down. So then essentially the head moves up. So there it is. So that's my model. So I can when I get a chance, probably tomorrow, send it to 3D printer and wait a little bit. In 20 minutes, I should have a little knob. Any questions about saving it for 3D printing or anything about Makerbot that you guys want to know?